consider SDP, which is not directly, well, it's less or more in the standard form, but we first do it like, I mean, it can be an exercise. First it was really the general stuff. I prove it, find Lagrangian and the viral, and so now it's more concrete example about it, and so it can be really funny to do it. So yeah, such a trace of b equal 1, p is this semi-positive definite, and it is maybe not clear, but let's see what's p the primal is capturing about the matrix H at this point. So let us do it like at the dual problem, which will give us a simpler insight. So we confirm the Lagrangian of the problem, which as we see in the last video, we can try to just transform those constraints into indicators functions. So e of trace of p equal 1 is equal to inf of, because it's an equality, you can take lambda, for example, lambda e into r of 1 minus trace of p, and we have I of p being semi-positive definite of p, and so we just can write this trace of p, pz, why not? What? That's inf z being semi-positive definite. And so now we can just rewrite the problem. P star is equal P star is equal to sub of p of nth of lambda I into r, and set separates to 0. This does not change. Trace of pH. And I wonder if I must add the sums into it, but I think it's okay, like to just write it by. Ah, yeah, sorry. So put it like this: plus lambda of 1 minus trace of p plus trace of p z. So we have this, and so after to we have that the Lagrangian is just this. It's just so p lambda z such that we have trace of pH plus lambda multiplied by 1 minus trace of p. That's so cool to calculate Lagrangian at the end. I was afraid of it at the beginning, but now I just feel like what's all the point of convex optimization if we don't have Lagrangian? I mean, I already knew it, but I was afraid. But once you master it, I just want to do other exercises about it right now because it's so satisfying to see all this power, this knowledge. Anyway, so yeah, so p star at the end is just equal to sup of p of nth of lambda I being into r with z being superior to 0 of Lagrangian p of lambda thing, and so that's inferior to nth of sup. See my geometrical explanation of it in the general framework for understanding how to go from the primal to the dual thanks to the Lagrangian for semi-definite programming, which is another video. Yes. And so if we if we rewrite it, it just so inf, let's just do constraints p of the trace of pH plus lambda multiplied by 1 minus trace of p plus trace of p c. And so, now that we arrived here, we'll do the same as before, where we try to factorize. So we see we can factorize by trace on p, and we take the stuff which is not correlated by outside. So lambda can go outside, and the rest is correlated by trace on p. So trace of p multiplied by h plus 1, no, minus 1, plus z. Okay, so I can try to write an indicator function about it. It's lambda trace of p, so that's lambda here. So as earlier, now I write it like this. Plus the trace, well, maybe I can directly write it like this, plus indicator function of h minus lambda plus z equal 0, depending on lambda and z, two constraints we introduced, and so h minus lambda is just equal to minus z. And so it's less from like, yeah, we can also say then less from equivalent to say h minus lambda is inferior, is like not semi-positive definite because z is semi-positive definite. So because this, yeah, now can write it like this. And so our dual is just than this is equal to sub of p of p of lambda, sorry, sorry, it's inf because we changed it like this. So it's inf of sub, inf of sub, inf of sub, and so if I follow the procedure, so wait, just here, the sub of p goes here, the sub of p goes here, and so we have p star is inferior to d star, which is equal to inf of lambda e of lambda, or even I don't know if I need to write it as a lambda e, like, because yeah, I mean here we can even take a lambda, because it's not a sum or stuff with a trace. So such that, and so yeah, and because it is matrices, you need to it is an a scalar, so you need to write it like this, and so sorry, you need to write this like this, like to multiply your scalar but something, and so you can write it now as h inferior to lambda I, and so you have lambda such that h is inferior to lambda I, like it's semi-positive definite inferior, and yeah, that's it. That's your new constraint. So now let's check if p star equals d star to see if there is a strong duality. So as we said earlier, we will try to use I because it's useful. So looking at the primal problem, if we take like p equal I over n, then we have like uh, then we have our primal problem that can be, then p star will be written like this. Such that trace of I over n strictly supersort is mean coordinates as I over n being this. but this is also is like you have this too, because I have is already like this. So because I is like this, then 1 over n by I is also like this. And so it respects this latter theorem because the primal is dp strictly feasible, so b star equal d star, and is achieved for some p normally. So the inf can be replaced by a mean, because there is strong duality. That we saw thanks to Slater theorem. So yeah, that's cool.